Here is Mr. Ramesh Chandra, the author of the book Subtraction and Combination, with debate from IIT Kanpur, and taking a lecture on complex number. First of all, we need to know about why we study complex number. What is the need of complex number when we have different kind of numbers like rational number, irrational number, and real numbers. More precisely, real number. What is the need of complex number if we have a real number? And what was the need to study complex number? As per theory of equation, we know that a equation or a polynomial of degree n has n number of roots or 0, like x square minus 1 is equal to 0 has 2 roots, as we can write it as x minus 1, x plus 1 is equal to 0, so x equal to 1 and minus 1 are 2 roots. Quadratic equation, this is a quadratic equation having 2 roots, 1 and minus 1, and these two numbers are real numbers, belongs to real numbers. Now let us have one more equation, that is x square plus 1 is equal to 0. Think about this equation. Here we can see that this can be written as x square is minus 1. So we know that for any real number, if we square that real number, we always get a positive number. We always get a positive number. So there is no any real number whom square is equal to minus 1. Since this is a quadratic equation, this has 2 roots. So there must be some number that we already know, like real. It means that if there is no any real number which satisfy this quadratic equation, x square equal to minus 1, then there must be some another kind of numbers. We define x square is equal to minus 1 as x equal to plus minus under root minus 1. Under root of minus 1 is equal to iota. We define it, we call this as iota, I-O-T-A, iota. And this is an imaginary number that we call it. So for the equation x square plus 1 is equal to 0, we can say that we have root like x is equal to plus minus iota, or x equal to plus minus under root of minus 1. Since under root of minus 1 is equal to, we have defined iota, so there may be the case like I square is equal to minus 1, I cube is equal to, if we multiply by I, then we will get minus 1 into I, that is minus I. I to the power 4, if we again multiply I both sides, then we will get minus of I into I, that is minus I square. And what we are getting I square is minus 1. So minus 1 into minus of minus 1, that is equal to 1. So I to the power 4 is equal to 1. Again, now I to the power 5 is equal to, again multiply by I in this equation. So we are getting I to the power 6 become is equal to I square, that is minus 1. I to the power 7 is equal to minus I to the power 8 is equal to 1. Again, I to the power 9 is equal to 1 into I to the power 10 is equal to I square, that is minus 1. I to the power 11 is equal to minus I, and I to the power 12 is equal to 1. So what you are observing here, that I is this, I to the power 5 I to the power 9 is I, and we are getting the repeated value, and you can see that I to the power 4 is equal to 1, I to the power 8 is equal to 1, and I to the power 12 is equal to 1, and this will repeat after 4. So what we are getting here is we have a number like I to the power 4k, where k belongs to integer. So I to the power 4k, what we are getting? 1. देख सकते हैं उसमें I to the power 5, if we divide 5 by 4, then we will get remainder 1, so this is I. If we divide 9 by 4, then still we get remainder 1, so this is I. So 1, 5, 9, these are the number of kind I to the power 4k plus 1, and this what we are getting? I to the power 4k plus 2 is equal to minus I square, that is minus 1, and I to the power 4k plus 3 is equal to minus I, and so on. So here you can see that we have these 4 important results in the case of iota. I to the power 4, like I to the power 60, this is divisible by 4, this is this type, so this is equal to 1. And I to the power 75, what kind it is? We divide it by 4, then we are getting 3 as a remainder. 4, 3 as a remainder. So this is of kind 4k plus 3 type, so minus I. We divide it by 4, what we are getting here? You can see this is, we are getting 75 is of 4k plus 3 type. Similarly, we can have I to the power 1001. This is of kind 4k plus 1 type. So this is equal to I, we can write this. So let us solve some questions based on the value iota, based on the concept iota. Find the value of first 1 plus I square plus I cube plus and so on up to I to the power 100. Second, 1 minus I plus I square minus I cube plus I to the power 4 minus and so on till I to the power 100. Third, 1 plus 1 upon I plus 1 upon I square plus 1 upon I cube plus 1 upon I to the power 4 and so on up to 1 upon I to the power 100. Fourth, let's solve this. We can also solve it simultaneously. Let us think of question number 1, first part, that is 1 plus I square plus I cube plus I to up to I to the power 100. So what we are getting here is 1 plus I square is minus 1, I cube is minus I, so minus I to the power 4 will be 1. Then again we will have I minus 1 minus I, and again the sequence We will like this. 4. We can make pair of 4 like this. And there will be a number at the end, and so on, plus I to power 100 is 1. So you can see that there are 101 terms. You can see 1, 2, 3, 100, and there is one more 101 terms. So what we will have at the end? We will remain this as a number, since these are becoming equal to 0. In every 4 pair, this is becoming equal to 0. So the answer for this question is 1. So this was question number 1. Now question number 2. What we have here is, again we have 101 term. You can see there is 101 term. If you think of these numbers, even you can apply geometric progression as well. There is a common ratio of minus I. So this is a geometric progression having number of term 101. So this can be written as 1 times minus I to the power 101 minus 1 upon minus I minus 1. This is the formula for the sum of nth term of a GP, that is A times R to the power n minus 1 upon R minus 1, that is Sn, sum of n term of a GP formula. So minus I to the power 101 can be written as minus of iota to the power 1 minus iota to the power 101, and I to the power 101 can be written as minus iota minus 1 upon minus iota minus 1. So again what we are getting, we can cancel these out, that is 1. So answer for the second part is also 1. Even you can think different way. You can make it pair of 4, like you can have here, that is 1 minus I minus 1 minus I is plus iota. So what you are getting here, you can get this is equal to 0. You can get this is equal to 0. This is equal to 0. So at the end what we will get, since there is 101, you will get this I to the power 100 as a single term, and that is equal to 1. So you can think differently as well. Now here we have third part, that is 1 plus 1 upon I plus 1 upon I square and so on. Here what we can have here I to the power 4 is equal to 1. I square can be written as minus 1, and I to the power 3 can be written as minus I. So if we think of 1 upon I, then we can have I to the power 3, that is I to the power 3 upon 1, that is minus I. So what we can have, 1 upon I can be written as minus I, or this can be derived from here as well. If you think of this, so 1 upon I can be written as minus I, and 1 upon I is equal to minus. What we can have is 1, this can be written as 1 upon I can be written as minus iota. I square is minus 1, so this is minus 1. 1 upon I is iota plus I. Again this is 1, and again we have cycle like this. We will have same cycle like this. 1 minus I 1 plus I, 1 minus I minus 1 plus I, and so on. Again you can see that there are 101 terms. So they will remain 1 upon iota to the power 100. So again, what we are getting here is this term is becoming 0, this term is becoming 0, and what remain is this, and this is equal to 1. So the answer for the third part is also 1. So these three questions, both these three questions, all are having answer as 1. Now let us have another question. Next question, question number 2. You can solve it your own before proceeding. The sequence is s is equal to iota plus 2 iota square plus 3 iota cube plus 4 iota power 4 plus up to 100 terms simplifies to fill in the blank where I is equal to under root of minus 1. Okay. There are 4 options. Then we can have 4 options as well. A 50, 1 minus iota. B option 25i. C option 25 times 1 plus I. D option 100 times 1 minus iota. When we can simplify it to a number, it's better to have some options here. So you can choose any one of them. There is only one answer is correct. You can solve it your own. First solve it your own, then you can look at the answer. So let us have S. So S is this one. No? If you observe this, this is an arithmetic geometric progression. And this arithmetic geometric progression, AGP, arithmetic geometric progression, and it has 100 terms. So 100 term must be of kind 100 iota to the power 100. So if we multiply it by iota s, then this must be I square plus 2i cube plus 3 iota to the power 4 and so on plus 99 iota to the power 100 plus 100 iota to the power 101. Since this is AGP, arithmetic geometric progression, so we can apply the rule of AGP, that is, we apply when calculate the sum of arithmetic geometric progression. Let us subtract it. S minus iota s is equal to iota plus iota square. In this case, to be subtracted from this in this. So what we are getting here, plus iota cube and so on, plus iota to the power 100 and minus 100 times iota to the power 101. Please look at this expression. So this is what we are having here. This is from 1 to 100 and it is having 100 term, and you can see that this can be equal to 0. If you observe, if you solve it, this will be 0. From above you can get it, from here you can get it, What we are getting? This 101. It remain this one, and then the rest is 0. So here we can take as common 1 minus iota is equal to minus 100 times 1 iota to the power 101, and this can be written as 100 times iota or OV minus. So s is equal to can be written as 100 times iota upon iota minus 1. I have removed minus sign by interchanging the sign of this. So to get the value of s, we can multiply it by minus iota minus 1, or yes, we can multiply it by minus iota minus 1, minus iota minus 1. So what we are getting here? 100 times I, if we multiply I by minus I, so minus I square, that is 1, and I minus 1 minus I upon what it is, a minus b, a minus a, this is like a square, a plus b, a minus b, so this is a square minus b square, that is 1 minus iota square, that is 2. So 100 times 1 minus iota upon 2. You can see it. If you multiply it by, you will get 2. And so this is 50 times 1 minus iota. Here you may get confused due to negative sign. So let us have some another. We can remain minus sign as it is. S is equal to minus 100 iota upon 1 minus iota. Here we are getting a little bit confusing. So we can multiply it 1 plus iota, 1 plus iota. So this is easy to tackle the situation. What it is? Minus 100 times iota minus 1, iota minus iota square, that is minus 1 upon a minus b, a plus b, that is a square minus b square. So 1 minus minus 1, that is 1. So 2 it is. So you can multiply, divide by 2, and you will get 50 times 1 minus. You can see which one is the correct option. 50 times 1 minus iota. So A is the correct option. Right, the next question we have. Question number third. If z plus zq is equal to 0, then find the root of roots of a quotient of given equation. What we can have here is, we take common z as common, then we will get 1 plus z square is equal to 0. So z square plus 1 into z is equal to 0 can be written as z minus iota, z plus iota, z is equal to 0. So apply z is equal to 0 iota then minus iota. So these are the roots of this cubic equation. Solve another question. We have another question, question number 4. Solve it before watching answer. Question number 4. Solve the quadratic equation. Solve the quadratic quotient z square minus 1 plus 2 iota times z plus iota minus 1 is equal to 0. Or solve your own, only then proceed to the solution. When I am discussing the solution, we can see that ax square plus bx plus c is equal to 0, where a, b, c belongs to complex number, a not equal to 0 is a quadratic equation. Here you can see that in this case a is 1, b is minus of 1 plus 2 iota times z, plus c is in I minus 1 is equal to 0 to be compared by this equation. So we can apply the rule, we can apply the formula of ax square plus bx plus c equal to 0, that Colsey-Dachar method, that is x equal to minus b plus minus under root b square minus 4ac upon 2a to solve this equation. But we can, if we observe the equation, then we can easily find out some solution. We can split the given equation in two parts. By factor, we can solve this equation by factorization method as well, if we can. Yes, we can go with this formula. So before moving on this formula, let us observe this equation. What we have is iota minus 1 as a c. So we think of this equation, then we can written as z square minus, what we can write it as 1 plus iota times z plus iota times 1 plus iota. We split two parts like a factorization. What we do? We need to split in such a way that their sum is equal to this, and the product must be I times the product must be this part. You can see I minus I square, that is minus 1. So z square minus 1 plus iota times z minus iota times z plus iota times 1 plus iota is equal to 0. If we have z as common, then we can say that z minus of 1 plus iota. Here we can have minus iota is common, so we can have z minus of 1 plus iota is equal to 0. So z minus iota into z minus 1 plus iota is equal to 0. So z is equal to iota and 1 plus iota. So these are the roots of the given equation. If we solve this by using this formula, then still we can get the answer. That is, we are getting the solution for the same equation by using the formula. What we can have is x is equal to minus b, that is 1 plus 2 iota plus minus under root of b square minus 4ac, 1 plus 2 iota b square minus 4a 1 c iota minus 1 upon 2a. So x is equal to 1 plus 2 iota plus minus under root. What we can have here is 1 minus 4 plus 4 iota minus 4 iota plus 4 upon 2. You can see that this will get cancelled out. 4 also get cancelled out. It will remain 1. X is equal to 1 plus 2 iota plus minus 1 on 2. If we take plus sign as first place we have plus sign, then we will 2 plus 2 iota by 2. So x is equal to 1 plus iota. We have minus sign, this and get cancel out and will remain iota as. Thank you. In this lecture we have these 3-4 questions and the basic meaning of complex number. In the next video, we will have definition of complex number. We will categorize or classify complex number. Okay, so it's